That's it. Today in this video we are just going to discuss about the light energy. You are seeing just light energy. We are continuing, and previously we have already discussed about the just refraction. Okay, what are the laws of refraction are there, and what are their phenomena are taking place in this video. That is we are continuing light energy. In this video we are starting with a very uh, important concept, that is the refractive index. Okay, so what is the refractive index? The condition arises in our mind that what is a refractive index. Refractive index is a very important property of just light. Okay, that is when a light just enters in another medium, or just refraction takes place. So it is having some just bending, or it has amount of just light is just too bend when it enters in the denser medium. Okay, from the rarer medium to the denser medium. Okay, so it is that property in which the just amount of light is just get reduced, or it just refracted, or some it is just bent. Okay, so what is the amount through which the light when enters in the rarer medium to denser medium, how it get reduced, how it bent sharply, and all these phenomena just defines the refractive index. Okay, just determined by the refractive index. And we know that refractive index is defined as the just the speed of light. This is c small c, that is c is denoted as speed of light. So a refractive index of any body is the ratio of the speed of light in air or vacuum to the velocity or a speed of just light in medium. Okay, suppose a light is entering from the rarer medium to the denser medium, so in that case we will able to define the refractive index, that whenever a ray of light is just entering from the rarer medium to the denser medium, the refractive index may be defined as the refractive index is defined as a ratio of the speed of light in air or vacuum to the speed of light in vacuum in which is entering. Okay, and we also know that the speed of light in vacuum or air is 3 into 10 power 8 meter per second, and it is obvious that speed of light is always greater than the speed of light in vacuum, because as soon as just light enters in any medium, suppose just denser medium, suppose water, glass, okay, or we can say the diamond, in any medium it is entering, the speed of light gradually decreases, the refractive index gradually decreases. Why? Because the speed of light just goes on decreasing from rarer to the denser medium. This is obvious, this is the criteria, this is the condition. Okay, so here, since the velocity of light or a speed of light is just greater than the velocity speed of light in medium, just here I have written as the refractive index of any medium is greater than 1. Okay, in that case the refractive index of any medium is greater than 1. Suppose if you talk about the refractive index of just glass, the refractive index of glass is also greater than 1, water is also greater than 1. So due to the just speed of light is just having greater than just greater as compared to the speed of light in just in medium, in that case the refractive index of any medium is always greater than 1. In that case it just defines the refractive index. Okay, so under that condition you have to understand, so what is the criteria which gives the refractive index? It gives the amount by which the speed of light get reduced, means how much percentage of light is just reducing. Okay, when is just entering into the denser medium from the rarer medium. Okay, and it also defines the amount by which the light ray is refracted or bent. This thing I have told earlier. Okay, so one of the great factor of refraction, we are talking about the refraction, we are just discussing about the refraction. So one of the great main factor is density, means how the denser the material is. Okay, in just refractive index also differs. Okay, so we will talk the condition of refraction one by one. Suppose we are talking just this first condition, that is when a ray of light is just coming from the denser medium. Suppose this is denser medium. Okay, suppose it may be glass or it may be water. Okay, this is denser medium. Okay, this is denser medium, this is denser medium, this is denser medium. Suppose this is denser medium and this is rarer medium. Okay, this is air or some air, we can say that. So whenever a ray of light is entering just going from the denser medium to rarer medium, okay, in that case angle of refraction becomes greater than angle of incidence. Means this angle of refraction becomes greater than angle of incidence. That is, we can talk that, we can say that this is normal. Okay, that is when a ray of light is just going from the denser medium to the rare medium, it just goes away from the normal. Means it just goes away means it just bent towards, not towards, it just away from the normal. Okay, far away from the normal, we can say that. And in that case the angle of refraction is always greater than incidence. This is the one of the main criteria of just refraction of light. That is, when if you talk about when just this is rarer medium, suppose we can say that this is rarer medium, or we can say that air, okay, or vacuum, and this is denser medium. Suppose it is water or glass, something else, something like that. Okay, suppose this is denser medium. Okay, so in this case if you talk about that when a ray of light is entering from the rarer medium to the denser medium, the just ray of light come towards the normal. Means angle of incidence, angle of refraction in this case is less than the angle of incidence. Here you see the ray is refracting here from the denser medium and just to the in denser medium is towards the normal. Means it is just coming nearer to normal. So this is the second case. And the third case, if a ray of light is just incident normally, okay, at 90 degree and normally at the surface, then it goes undeviated. Means there will not be any deviation of the light. So these are the three conditions you have to know about that. And just I am recalling that when a ray of light is just going from the denser medium to the rarer medium, angle of refraction is greater than angle of incidence. That is, it is just coming away from the normal. When the incidence of light is just incidenting on rarer medium to denser medium, then it is just refracting towards the normal. And if the ray of light is incident normally on any surfaces from rarer to denser medium, suppose this is glass, okay, this is glass, this is denser medium. In this case the ray of light just goes undeviated. Means there will not be any refraction. That is, the angle of incidence equal to the angle of refraction equal to 0. Means both the angles are 0. That is angle of incidence also and angle of refraction also. Okay, so now just here in your topic we are talking about the curved surfaces, spherical surfaces. So we know that what is spherical surface. Just that is spherical mirrors are here we are talking about the spherical mirror. That is, spherical mirrors are those mirrors in which it is a part from the spherical hollow sphere. Okay, we just take about a part, we just taking the part of any hollow sphere and we just cut it out, or we can take this portion. Okay, and if you just paint from the outside and the reflecting surfaces from the inside, then it is always a concave mirror. It is always a concave mirror. That is, in case of concave mirror, if you take a part of any hollow sphere and we just take it, and after that we will just paint from the silver nitrate, or there are so many compounds are there. If you just paint it from the outside and the reflecting surface will be inside, then this type of mirror is called as the concave mirror. This is called concave mirror. And if we just take a part of any spherical hollow sphere, and it is bent from the inside, and the reflecting surface will be this bulging side. Means the reflecting surface is outside and the painted from the inside. So in this case it will be always a convex mirror. This will be convex mirror. So this is the condition. Okay, so when the bulging part of any spherical mirror, okay, is just painted, and the reflecting sides and the internal side is the reflecting surface, this is concave mirror. And when the internal side means the just compressed side, we can say that is a painted, and the outside is a reflecting surface, then this type of mirror is called as a convex mirror. So these are the criteria. And here we are seeing that this, if you painted from the outside, this is spherical mirror, okay, this is painted from the outside, reflecting surface is from the inside. Okay, here just see the diagram here. Okay, when the parallel beam of light, when a parallel beam of light is just coming from the infinity and it just passes through focus, here is a focus. Okay, here is a focus, so it will just always converge. Okay, it always converges to some particular point on the principal, this is principal axis, on the principal axis this is called as a focus, and it forms always a real image, it forms always a real image. And also it is also called as a converging lens, it is also converging mirror because it is converging towards the focus. Okay, concave mirror is also called as the converging mirror. Okay, and what happens if the just we are painting just inside and the reflecting surface is outside, then when the parallel beam of light is just coming from the infinity, then it diverges. Okay, and if we extend the dotted line, that is virtually, then we are getting the focus here. So this is called as the diverging mirror, means convex mirror is diverging mirror. Okay, so this is all about the concave mirror and convex mirror. And dear student, now we are going to discuss some condition that how the related terms are just here. Okay student, here in this case we will talk some related terms regarding the spherical mirrors. Okay, first one is the center of sphere and the center of curvature. This is center of curvature. Okay, and the center of curvature may be defined as it is a center of a sphere, this hollow sphere, it is the center of the hollow sphere of which spherical mirror forms a part. Okay, means spherical mirror is a part of the total hollow sphere. So it is the center of the hollow sphere in which the spherical mirror becomes a part. It is a part, it is obviously it's a part. So this is called as the center of curvature, and it is also denoted by capital C. What is radius of curvature? Radius of curvature is a total distance between the from the pole to the center of curvature, means the radius of a sphere of which the spherical mirror forms a part, or we can say that it is a total distance between the pole and center of curvature is called radius of curvature. Or we can say that in different way, that the radius of sphere of which the spherical mirror forms a part, it is also a part. Okay, so it is called as a radius of curvature. So this is called as a from the pole to the this is radius of curvature, radius of curvature. Okay, and if you talk about the pole, this is pole. The other name of pole is also vertex. So what is pole? The midpoint of a spherical mirror. Suppose we are cutting out this spherical mirror and painted from out, we are considering the concave mirror. Okay, refracting surface painted from the outside. So if you are taking a part of any hollow sphere as a concave mirror, so this is what? This is pole. Okay, this is the midpoint. This is the midpoint of the spherical mirror. So whatever the midpoint where the principal axis just come at meet here along with the center of curvature. So this is the midpoint of any spherical. This only this much you understand. This is the midpoint of any spherical surface is called as the pole. Okay. And what is principal axis? Principal axis, we can say the imaginary line, or we can say that line joining the center of curvature and pole, only this much. Okay, means any imaginary line which joins the center of curvature to pole. This is called as the principal axis. What is aperture? Just see it. What is aperture? This perpendicular line, this diameter, okay, this diameter is called as aperture. What is aperture? Aperture of mirror is the effective diameter, means it is the effective diameter of light reflecting surface area of mirror, means it is a total diameter up to which the reflecting surface is occurring here. The area of the reflecting surface came into existence, means this is the effective diameter over which light reflecting area of the mirror occurs. This is the light reflecting area. So what, this is the diameter from this point to this point, this is the effective diameter, and among each and every part it becomes it is the effective area of the just reflecting portion. So effective diameter of light reflecting area of the spherical mirror is called as the aperture. And what is principal, what is the focal length? What is the focal length? The distance between the pole and principal focus. If you talk here you see that here you see that if the parallel beam of light is coming, okay, and just is converging at focal point F, so this is pole, and the what will be the focal length? The total distance between the focus and the pole is called as the principal focus or a focal length. Focal length, okay, these are the condition. So all these are the just terms which are related. Okay, dear student, we will meet in the next video with some new video with new topics, okay, up to go through. Thank you.